Great, so I'm Ben Foreman, I work for Prime Video, I'm based out of London. I did have a bunch of fun questions to ask just to get the energy in the room going, but they were all about poor experiences that people might have had on digital video and OTT streaming services and how Prime Video is interested in making these things better. But I've sat through the presentations this afternoon and I can tell that every single one of you is interested anyway in making video better for consumers. So I will want to get the energy going a little bit. So just out of interest, how many people have watched live streaming on Prime Video? When we have that raised hands. Great, and if you could, keep your hands raised. And you're lucky, I'm a martial arts instructor in my spare time. I'm just getting you to answer questions, not bounce about. So those of you, keep your hands raised if you've watched live streaming on Amazon channels rather than a live sports event. Interesting. Okay, so I'm going to talk a bit about Prime Video, a bit about how we do live streaming. I'm going to specifically talk about how we do that on Prime Video channels and how we do it for fast services. So I'm going to talk about the dimensions by which we look at this: observability, reliability, cost optimization, security, and sustainability. And we touched on some of these things already in the sessions this afternoon. We've talked about observability, and we've talked about reliability, and we've talked about security as well. And for those of you that are familiar with the AWS well-architected framework, it also is focused around some of these areas of operational excellence, performance efficiency, security, cost optimization, reliability, and sustainability. And the message that I want you guys to take away from this today is that all of these dimensions can be optimized. I don't want you to go away thinking that they're trade-offs or that you have to sacrifice one in order to improve another. They can all be improved and they're all complementary, can be considered complementary to each other. So as I said, I work for Prime Video. I'm the global head of live channels architecture. I've been with Prime Video for around, just coming up for 7 years now. Before I was at Prime Video, I worked at Sky for 5.5 years, and I was responsible for building the live streaming architecture for Sky Go. That evolved into supporting Now TV and Sky Sports and Sky News. Worked at BBC Technology for a little while, and a very long time ago I set up the live streaming for Premium TV, and that eventually evolved into the company that some of you probably know as DAZN. In fact, I've been working with digital video since I was about 14, when my uncle showed me that I could use his video capture card on his Mac SE to edit his holiday video, and I spent a week capturing still images of Terminator 2, which was much more interesting than the holiday video. At Prime Video, I'm responsible for various scaling and cost optimization work. I'm responsible for building automation systems so that we can onboard and support today about over 1,000 live TV stations on our platform. And just to give you an idea of how that's scaled, when we talk about scale in a lot of these talks today, when I joined Prime Video 7 years ago, we had 16 stations live in the US only, and as I say, we have over 1,000 live today, I think in 12 different countries. So very quickly, just talk about what those services are and how sort of Prime Video differentiates itself from other services. We have, let's say, three offerings within Prime Video. There's an advertising-based service, there's a subscription service, the Prime Benefit, and there's a marketplace. So the advertising-based service is Freevee. It's launched in, I think, 5 different countries, and we have a number of live streaming services. So what everybody knows probably in here is FAST channels, free ad-supported TV. Within SVOD, so your Prime Benefit, the things that you get when you subscribe to Amazon Prime, we have live streaming services such as Thursday Night Football in the US, various... Oh, sorry. I'm too short to stand behind the thing. I don't want to disappear behind it. So I'll try and stay by the mic. So we have Thursday Night Football in the US. We have a bunch of soccer services in different parts of the world, primarily in Europe, but also Brazil. And then we've recently streamed live World Baseball Classic in Japan, and we have some boxing events in Japan as well. We've got various news services that were really popular during COVID. And in Germany, we provide free-to-air services as well, so local and regional TV stations. And then finally, the marketplace. Again, for those of you that are... Right, it's okay. I'll just mumble if I use that. The rentals and purchases that we have on Prime Video, but we also have a marketplace which is through which you can subscribe to TV services. So in the US, you can subscribe to HBO, you can subscribe to Paramount Plus, you can subscribe to Discovery in a whole bunch of different countries. And within that service, those partners that we work with, their subscriptions offerings also often include live video as well. So one way to think about it is if you're in the UK, you can watch English Premier League as part of your SVOD benefit. If you're in the US, you can watch English Premier League as part of your Paramount subscription. So the core of our platform is built around elemental services, Media Connect, Media Live, Media Package. And then, as well as that, I mean, there's a whole bunch of other AWS services that we use, obviously, but I've chosen just to focus on these 5 because they're relevant to the presentation that I want to give. So we use EC2 and S3 as part of our video delivery pipeline and some processing. We use CloudWatch for gathering metrics, and we collect cost and usage reports from our AWS accounts and services, and we analyze them in QuickSight so that we can assess the cost of our service. So on to that first topic of observability, and I'm going to just start with a quote. It's one of my favorite quotes: "You can't manage what you can't measure." And what I want to talk about is a little bit about how we measure the reliability of our service. So the first thing in any service, running any business, is you want to identify the metrics which are critical to the business. So for us, those are availability, performance, quality, and cost. And just to talk about those a little bit. So availability, we can think about that as uptime. Somebody mentioned it earlier. One of the other presentations talked about 5 nines uptime. That means our service has to be available to customers, or it means we allow downtime. It's not really allowed, but accepted downtime of less than 26 seconds per month. For performance, we're looking at the metrics that are associated with how the service is performing. Direct Connect, Media Connect, Media Live, they all emit various metrics which we can collect and we can use to understand a little bit about the service health. The quality metrics that we talk about are probably a bit more indirect. They're a bit more about the perceptual quality, the quality that the customer might be experiencing. So they may be elements of the video stream, such as the bit rate and the resolution, the frame rate, or the latency. They might be delivery metrics like the amount of buffering customers are experiencing, or the percentage of available HD fragments they get, the time to startup, time to first frame. And then, we might measure different interfaces as well. So we have video quality monitoring, and that might look at, the actual perceptual quality of the video, whether there's macro blocking, whether it's black to air, whether the volume's too high or too low or gone entirely. And finally, cost, which we'll talk about in a little bit. So we have all of these metrics, and we use them for kind of 2 purposes, let's say, broadly speaking. We're collecting them from the services, we're collecting them from the interfaces, and it's giving us the opportunity to build up a holistic picture of the health of our platform, interface by interface and service by service. And we can do that to drive continuous improvement initiatives, and we also can use it to drive immediate change for customers, so that if there is a degradation in quality at some point along the pipeline, we can make decisions automatically which protect customers from poor experience. I'm going to give a couple of quick examples here, and the screenshot shows a sports event in 2017 on the right, and on the left, just some customer feedback on an event more recently. The 2 examples I want to give briefly, one of them relates to signal impairment caused by a capacity overflow on a network in a remote data center. It wasn't something that we had any control over. It was at a partner facility, and it resulted in the video being contributed to us looking like that, in fact. The second example, similarly, is around satellite downlink. So I mentioned we have this uptime requirement of 5 nines. We can satisfy the uptime requirement if we have to downlink satellite by having 2 satellite downlink locations. If one goes down, the other one's up. However, the 5.9's availability doesn't necessarily mean that the performance is acceptable. Just because it's up doesn't mean it looks great. And so with the monitoring that we have in place today and that we've developed over the last few years, when there's a picture quality issue, we're able to identify it much more quickly. We're able to protect the customer, or we're able to make a long-term decision. And in this case, for the example of satellite, we're increasingly moving away from satellite downlink and moving to direct connections with partners so that they can contribute video to us without having too many intermediate services that are not in anyone's control. So once we've got those metrics, what do we do with them? Let's talk about reliability for a second. And the reason I've shown this picture of the World Cup winning team is because Prime Video Channels has actually broadcast the World Cup in, I think, 5 different countries over the winter. So although, many of you were saying that you'd not seen Prime Video Channels, Prime Video Channels was a place in Germany, in France, in UK, and in Mexico, where people went to watch the World Cup final. And another quote, another really good one from Werner Vogel's, another of my favorites: everything fails all of the time. And the question that I want to sort of approach in the next couple of slides is, how do we build a highly available and highly reliable television platform that's always there when customers turn it on, when we know that running services in the cloud is not the same as running broadcast transmitters and satellites in the sky? And I'm just going to focus on this specific area here of a Media Connect, Media Live, and Media Package, each of which have an advertised SLA on the AWS website of 3 nines, which is equivalent to 43 minutes downtime per month. When you run them all in sequence together, the overall availability becomes a function of that, and the total availability is 99.7, which is a downtime of 2 hours, 10 minutes, and 24 seconds per month. And so you can see this isn't close to the 5 nines that we're looking for. However, when we run these services, we run them in sequence, and then we run them in parallel. And so by deploying these 2 systems in 2 different regions, we meet our availability metric of 5 nines. In fact, 5 nines and a 1, which is equivalent to 23 seconds downtime per month. So what does that mean in practical terms? If we accept that there is going to be some downtime, some performance degradation along the way, how do we make sure that we build a system which is architected to protect customers from those issues? I'm just going to talk about 3 ways in which we do that. So on the left-hand side of this drawing, you can see there are 2 video sources. The 2 video sources are transmitted, from the 2 video sources are transmitted 4 signals over 2 direct connects into 2 different elemental pipelines. The construction of this pipeline means that if one of those video sources disappears, if it's degraded, or if it fails, the signal is still delivered to both pipelines. And so from a customer point of view, we enable the failover, let's say, at the elemental Media Connect, and it can choose between the 2 sources that go into it. The failover at Media Connect is almost seamless, and that means as a customer consuming that video, watching that soccer game, that boxing match, if there's a failure to the left of the direct connect, there might be a small amount of macro blocking, but effectively the consistency of the stream through the pipeline is maintained, and the customer continues to receive it. The second thing to talk about is an elemental deployment model. It's called standard channel deployment. And with standard channel deployment, the Media Live is deployed for a single channel. The Media Live is deployed in 2 availability zones. Media Package is distributed already across multiple availability zones. And what that means is when the signals come through the pipeline, and both signals are effectively available in 2 availability zones, but in 1 logical Media Live, if there's a failure of the Media Live or a failure of the signal, that failure is abstracted away from the Media Package on the far left-hand side. The Media Package is choosing at any given moment the healthy signals from either of those Media Lives. And so from a customer perspective, whilst I'm consuming fragments from the Media Package is abstracting any failure behind it away. And so if something falls over, if something degrades, customer is unaware of that issue. And finally, we support a failover mode, which let's call client-side failover. And here we come back to what I was talking about before, where we are constantly collecting these metrics from different services, and we're using those metrics to take decisions. And so what happens is, if there's a problem along the way, if there's a failure along the way, the metrics collector, the data collected by the metrics collector is being analyzed, and it can go back to the client and send the client a message and say, fail over to one of the other streams that's available to you. When this happens, there is sometimes a small amount of buffering on the client side, but again, we're keeping the overall availability to the customer there, and their stream is maintained throughout. So I'm going to talk about cost optimization now. And another quote, more recent one, I think Andy Jassy said this in his recent letter to investors, which is that customers tell us that they're not cost-cutting as much as cost optimizing. And this is, one of the core messages, I think, to take away, which is, we can optimize everything. We're always looking to optimize everything. And that's what a lot of these presentations have touched on today. And so again, first thing we'll talk about is identifying the metrics which are critical to the business. Whether we're talking about availability or reliability, sustainability or cost, the principles are very much the same. We want to develop or identify a metric. We want to measure it, identify the levers that we have to influence that metric. I think somebody actually even used that phrase about identifying levers earlier on. We want to model those changes. We want to implement those changes. And so just to talk about those a little bit, what they mean for me as a sort of a service owner within Prime Video. As I said, there's over 1,000 stations on Prime Video today, and so an important metric that we developed was cost per station. As we have an increasing amount of sports content and an increasingly flexible platform, cost per station may be just one metric, and we may choose an additional metric like cost per hour or cost per event. We want to measure that metric, and so looking at the cost and usage reports that come out of AWS, we can assess and model the costs. Identifying the levers. So again, for a lot of these live video services and a lot of cloud services, the cost can be influenced by data transfer. So we want to look at opportunities to change or reduce the amount of data we're transferring. We want to model that. AWS provide a cost calculator, but we also use lots of Excel spreadsheets. It means we can put parameters into the spreadsheets, we can change those parameters, and we look at what comes out. And we want to implement those changes. And this is not like a single event. It's not like an annual event. This is what we call in Amazon terms a durable mechanism. We measure and we model and we implement. And we're continuously going through this cycle. And similar to what I was saying about reliability, we can use the techniques here to either make changes very quickly. So if we're alerted to spending that we're not anticipating or we haven't forecast, we can make a change for that. Or we can develop programs that drive down cost continuously, and that's one of the things that we do quite a lot. So just want to very quickly talk about how we do that. Each of these services that you can see here, they all have costs associated with them, obviously, and we capture those cost and usage reports every day, and we bring those cost and usage reports into QuickSight for analysis. Now, one of the capabilities that we leverage within AWS here is the opportunity to add cost allocation tags to these services. And what the cost allocation tag allows you to do is to create a metadata construct of a set of services. And so rather than looking at the price of Media Connect, Media Live, and Media Package, we can say, okay, how much does Eurosport 1 cost to run, or how much does HBO East cost to run? And we can visualize that in QuickSight, and it will give me, let's say, a stacked bar chart of the Media Live, the Media Connect, the Media Package cost, the AWS Direct cost, and any other kind of supplier cost that comes into that. And then we can use that to model the improvements that we want to make. I'm going to quickly talk about security as well. We're going to talk about security just in the context of network security, transport security, and content security. Obviously, for Prime Video, the most important thing is the content is protected from the moment it arrives with us or it leaves the camera until the moment it's watched by a customer. And so that means maintaining the integrity of the content throughout its life cycle, ensuring it's not accessible to anyone who's unauthorized. That includes systems internally that are not authorized. Ensure that it's not exposed externally other than the point of viewing, and that at the point of viewing it's only available to customers who are authorized to watch it, and to ensure that it's resilient to piracy. And so on the network side, we think about that, as a physical infrastructure over which the video is transported, and having those connections with partners, those physical connections with partners in data centers and between data centers ensures that. From a transport perspective, we choose video protocols that support encryption, and from a content perspective, we ensure that we're using, industry DRMs to ensure that content's secure. Sustainability. So again, Amazon is on a path to reach 100% renewable energy by 2025, which is 5 years ahead of its original commitment. And we've got the same drawing here again, this idea of measuring, modeling, and implementing and continuing to build processes around that. AWS released the well-architected review for sustainability in 2021, and they released the AWS Customer Carbon Footprint tool in 2022. And we've been able to leverage both of these mechanisms to help improve the sustainability of our platform. In fact, when the well-architected sustainability review was released, we were one of the first teams to take advantage of that. And we were provided recommendations by AWS on what we could do. By taking some of those recommendations and using the Customer Carbon Footprint tool, we've reduced our metric ton CO2 equivalent emissions down by 99.2% since December 2021. And there's two ways in which we've achieved that. One is, as the previous slide said, AWS is increasingly moving to sustainable energy sources. And so just by moving workloads into AWS, we're helping to meet sustainability goals. And secondly, we've taken, as I've said before, programmatic goals that enable us to reduce our carbon dioxide footprint. In this case, in this particular example, this metric comes from S3. And so, for our services with lots of live sporting events, we often provide highlights afterwards. And so with all of those events, we're generating lots of highlights. And so by coming up with mechanisms that enable us to manage the life cycle of those assets that are stored on S3 programmatically, we can make sure that we're only storing what we need to store, we're only storing really what customers are watching, and by driving that down over time, we improve our sustainability posture. So in conclusion, watching TV should just be like watching TV. Optimization doesn't have to mean trading off, and we can improve reliability and quality whilst reducing cost. And finally, I'm going to repeat, you can't manage what you can't measure. And that is all. I'm going to hand over to Ramsey, who's going to talk a little bit about some of Elemental's optimizations in the area of encoding. Thank you.